You will then how we can identify and measure inertia. Momentum, momentum is actually the first tool to measure inertia. There are two types of momentums. One is called linear momentum, which you have already done in unit 1. Second is two-dimensional momentum, which is unit number 4. Now I'm starting with linear momentum. Okay, I have given you mainly one concept. What is my first concept today? Momentum is a
Inertia.
measure of inertia. So when a
Yes.
train applies the brakes, you want to design some safety measure. For a passenger on a train, inertia is a feel. You cannot measure the inertia. Like you stand on a weighing machine, you can find your weight. You look at the clock, you measure the time. Inertia, unlike other quantities, is like a feel. Someone pushes you. This is inertia, which tries to hold you. So it is actually a field. So they thought, let's find a way to measure inertia. So momentum is a measure of inertia. There are two types of momentum in our course. Linear momentum in a straight line, 2D momentum when there are two dimensions involved. So we have to start now. Linear momentum. What is the definition? Momentum is a measure of inertia. Inertia depends upon two things, mass and velocity. How the inertia of a train coming up, it is due to mass and velocity. How the inertia of a bullet coming up, it is due to speed. How the inertia of a multi-wheeler comes in, it is mainly due to velocity, sorry, mainly due to mass. So linear momentum is the product of mass and velocity. Look at the definition and the formula. What is the formula for linear momentum? Momentum is equal to mass into velocity. What are the units? Kg ms minus 1, and second unit is Newton second. So can you recall the definition? What's the definition of linear momentum?
Linear momentum is the product of mass and velocity, and the
Yes,
unit is kg meter per second or Newton second.
yes.
Yes, so it's clear. We can move on.
You have to tell me the unit.
So the unit is kg meter per second or Newton second.
Yes. And then momentum is a vector. What direction momentum takes?
Term is a vector quantity. Same as the velocity.
Yes. Same as velocity. Now, dealing with microscopic particles. Microscopic particles are those Microscopic particles are those like proton, neutron, quarks, etc. We put our first concept here. What is the concept? We are dealing with microscopic particles. Microscopic particles are those which are like quarks, positron, neutron, proton. Gravitational effects are not considered. Why we do not consider gravitational effect? We see around us. Why the air molecules do not fall down? We leave a pencil and pencil goes down. Why the air molecules, why the atoms molecules, they do not fall down?
So are you asking me a question or are you explaining it?
I'm asking you that why little particles do not experience like a visual way of visually they do not experience any gravity.
So maybe because they are so tiny.
No, that's a wrong answer. You know why? Actually, tiny or bigger is not a concern. Gravity is the same. Feather and a stone, they experience the same gravity. Actually, that the main point is their speed. When you throw a ball with some speed, it slightly overcomes gravity. Microscopic particles do not experience gravity because their speed is very high. They're very energetic. My next concept. Microscopic particles mass is not in regular kg. They have a different unit called U. What U stands for? Unified mass constant or atomic mass unit. These are the masses which are coming from the periodic table. You will see this concept. You must have seen it in school, the very famous chapter, nuclear physics. So 23U, you have to convert it into kg. Look at the conversions which are given in the formula booklet: 1.66 times 10 power minus 27 rest mass of electron and rest mass of proton. These all values are given. What is my concept? For microscopic particles, masses are given in U, and you have to convert them. You have to convert them into kg. I repeat the concept. Microscopic particles mass is in U, and you have to convert them into kg. What about the microscopic particles energy? You know, energy is famous in joule, but for microscopic particles, what is the unit of energy? Electron volt. And
Electron.
the conversion 1.6 into 10 to power minus 19. So can you repeat the concept now for microscopic particles? What unit of energy we prefer?
Uh, Electron volt, and it has to be converted to joules.
Yes, electron volt, and it has to be converted into joule. Acha, this conversion, other conversions are obviously given. You just have to remember You just have to remember the conversion as a conversion memory, that how to use it. Isolated system, that was a concept in unit 1. In chapter of momentum, we asked this concept, that how much external forces are interfering. For example, there is a gas in a cylinder. Molecules are happily colliding with each other, no problem. Even though gravity is acting from outside, air pressure is there, they do not get worried about anything. So when a system is acted by multiple forces, but system is happy, it doesn't take the effect of external forces, such a system is called isolated system. These two molecules apply force on each other. A steel ball and a metal plate apply force on each other. They collide, rebound, but they do not take any effect. So now it's your turn. Give the heading isolated system.
Okay.
And now orally, no need to copy it. Orally tell me what is the meaning of an isolated system.
A system that is not affected by any external factor. So can you hear me?
Yes, I got the concept. The main thing in our Edexcel, you must have seen that they create a situation, they create a real type of situation in which they develop the question, and that's why we give examples like that. So they collide and they rebound. Comes a very important topic from our unit 1, impulse. What is impulse? See the definition. Impulse is the change in momentum. It's a vector also. Now, momentum is the product of mass and velocity. So momentum commonly changes due to change in velocity. Mass is generally a constant, even though in A level it should be a concept that mass as a nature is always constant, but about vehicles, about trailers, trains, mass varies because people get in, people leave out. So in that sense, mass is changing. Normally, momentum changes due to velocity. Look at this. Mass has a velocity u. The velocity becomes v. Look at the formula. Impulse delta p is equal to m bracket v minus u. So give the heading impulse and copy down the formula.
Yes, certain.
So Now, momentum and impulse have the same unit. I put an example of a gas molecule, one of the common example there. Molecule strike the wall because of its high kinetic energy. It is not worrying about gravity. The molecule rebound. After rebound, notice this that the velocity becomes negative.
Negative. Yeah.
Velocity becomes negative. So this is impulse. Delta P is equal to M. Delta P is equal to M bracket V minus U. As the rebound velocity is negative, I will get impulse is equal to minus 2 mv. Why it is 2 mv? Because it's a rebound case. The minus is a sign. Now we put our next concept. When two objects collide, like a ball collides a wall. So when a ball collides a wall, impulse actually comes in. Ball has an impulse, wall also has an impulse. So when you hit something, you have some impulse, and the object you are hitting also has an impulse. The two impulses are equal, but one of them is plus and one of them is negative. A very important concept sequence comes in now. When impulse is zero, it means momentum is constant. Velocity becomes constant. Acceleration becomes zero. It means it's a case of equilibrium. Equilibrium is one of the most important situation in our unit 1 physics and unit 2 also. That equilibrium means that something is either not moving at all or it is at rest. So go through this conceptual sequence. No need to copy it. You just have to explain me back.
So, like, what do I explain in exactly?
You have to explain the sequence.
So, as the particle is colliding back, so the direction of new velocity is negative. So, when we use the impulse formula, the change in momentum, so it will uh, like initially the direction was positive, then the direction is negative,
Hmm.
and they are both negative, so they will add up, and the final and the impulse will be minus 2 mu, 2 sorry,
No, no,
minus 2
impulse
mv.
here. Here impulse is zero. Here impulse is zero. It is a situation when impulse becomes zero. Now I give you this example. This is a past paper question. No need to copy the question. You have to remember the impulse of a rebound and you have to solve and find the impulse. Use a calculator.
Okay. So, it's 2 kg. Initially it's 10, negative 10 minus 20, so 22 into minus. So I got minus 60.
Good answer. And why the minus sign can be ignored? Actually, is showing minus sign is showing the other impulse. So other will be one will be 60, one will be minus 60. Now we move to our next concept, definition of force. I'm putting the definition force
So
is
actually,
the
I have one question.
sure.
Previously, you gave one example of momentum, uh,
Hmm,
like initially, where we got the answer as minus 2 mv.
hmm.
I had a similar question in past paper. I was solving it few days back, in MCQs. I'll share it with you on the WhatsApp. But I got the wrong answer. Let me share
No,
it
but
with you.
even here it is not 2 mv. This minus 60 example is not 2 mv. You know why? This is not an elastic rebound, this one. And the past paper question you're referring is also not a elastic rebound. 2 mv occurs that when only when you rebound with the same velocity.
Yes, sir, it was same. I have shared with you the question on WhatsApp.
Shared with the same.
Yeah, it is mentioned that it bounces off in the opposite direction at the same speed. and I got the answer as minus 2 MV, but in the marking scheme, the answer was 2 MV.
So he's asking for the wall now. This is something I was explaining right now, right? Look, I told you you got an answer. You got an answer minus 60. This is the ball. If the ball is minus 60, what about the ground? Ground will have plus 60.
Oh, okay.
It is the concept of Newton's third. I was explaining this actually right now when we started this point. It's a very good question you have asked. Look, this was a look. I have written negative sign can be ignored. When the ball and the wall collide, I gave the same example. If the ball is plus 60, wall will be minus 60 because the resultant impulse has to be zero. Otherwise, either the ball or the wall will break. If you sit on a chair and the chair doesn't break, it means your impulse and the chair impulse is equal. If not, the chair will break.
Okay, now I got the
So in
concept.
that MCQ, he was asking for the object, for the ball, but question asked for the wall. Acha, now what is the definition of the force? Look at the screen. Can you remember this definition? Force is
Rate of
the
change of
rate of
momentum. Yeah.
change of,
Momentum.
yes. And what's the formula? F is equal to impulse upon, F is
Impulse
equal
upon time.
impulse upon time. Absorb this formula, memorize it. Impulse is equal to then force into time. This is the second formula for impulse. Actually, this formula gives the unit Newton into second.
Okay.
This formula gives the unit Newton into second. Look at this.
Yeah, okay.
Force into time. Why the area is impulse? Because in our knowledge of unit 1 graphs, we say that area is the product of the two axes. Area is the product of the two axes. So force into time is impulse. Force into time is impulse. Look at this graph. First, I will narrate this graph, then you will have to. O to A, force increases. A to B, force becomes constant, and B to C, force decreases. Then force becomes zero. Remember, area shows impulse. So in the graph, remember that when resultant force becomes zero, acceleration becomes zero, velocity becomes constant, impulse becomes zero, and momentum becomes constant. Now, Newton's second law has a statement in our A2, force is equal to the rate of change of momentum. This is the definition of force also. This is the definition of force. This definition of force can be treated as Newton's second law. There are three Newton laws. Everyone has a statement, but this is the concise statement for second law. Now, let us talk about this formula. Force is equal to impulse upon time. Here, this time actually means time of contact. So when two objects collide, like two balls, like you jump on a, if you have a flavor, or if you like that jumping castle, so you have noticed that a jumping castle is designed in such a way that it goes in, compresses, and then you rebound. The bounce systems, the bouncing games, the bungee jumping, they all are good example of this concept, that you increase the time of contact. When you increase the time of contact, the force decreases. You must have seen the the racket of the long tennis which has a net. Why there is a net? Because in the tennis racket, the ball goes in and it will take some time and then it rebounds. This is the concept that time of contact increases. When time of contact increases, force decreases. The best example, is the jumping castle. When you jump on it, it goes in and rebounds. So it's a concept in collision science. You can save people by this approach by increasing the time of contact. A question like here, a hard ball, when it hits the glass, it will break the glass. A soft ball, when it hits the glass, it's possible it doesn't break it. Why? A soft ball will compresses on the glass and then rebound. So force will be less. Now, pressure of a gas. Give the heading pressure of a gas.
Okay.
Now, we put the theory here for discussion. Why gases exert pressure? Look at the molecules are moving randomly and elastically colliding with the container wall. Our course says that when molecule collide V and rebound minus V, there is an impulse. Impulse upon time is force and force upon area becomes the pressure. So impulse is the reason so why gases exert pressure. When they collide with the container wall, they rebound. When the rebound, velocity becomes negative. It causes an impulse. Impulse upon time is force, and force upon area is pressure. Very, very important topic comes in, which comes very oftenly in the paper. Law of conservation of linear momentum. This is actually the core of this initial part of chapter. So you have to give the heading law of conservation of linear momentum.
So isn't it the part of unit 2 or 1?
It's part of unit 2, but syllabus says that na, you have to follow the edexcel syllabus. They say for unit 4, momentum part, you must remember all of the unit 2 momentum part.
Okay. Yeah, I know this law. The momentum before collision and
Hmm.
after is conserved.
So you need to call back the definition. Total momentum before collision is equal to total momentum after collision.
Yeah. Momentum is conserved in an isolated system.
And total momentum before collision is equal to total momentum after collision. You will see this thing in A2, a very important thing to remember. Syllabus mention that you have to revise unit, this one from the previous unit, and you have to connect it here. M1 U1 plus M2 U2 is M1 V1 plus M2 V2. Now, conservation law and impulse. We have already discussed this MCQ. When two objects collide in an isolated system, they bear the same but opposite impulse. One has a is zero. So when you fire a gun, the bullet goes forward, gun recoils. How they get equal? They get equal because a bigger mass with smaller velocity and a smaller mass with bigger velocity, they get equated. Conservation of kinetic energy. Conservation of kinetic energy was a concept that in a collision, if total kinetic energy before collision equals total kinetic energy after collision, it means no energy loss. Kinetic energy is conserved. Now look at this M1 U1 squared plus M2 U2 squared. This theme is called conservation of kinetic energy. It means system does not lose any energy like sound, like heat, but this is a rare case. Now, there are two types of collision, elastic and inelastic. What are elastic collisions?
So where the momentum and the kinetic energy is conserved.
And also the total energy.
Okay, the total energy.
So gas molecules, are they colliding elastically? Look at this. This
Yeah, this
is
is an elastic
elastic.
collision.
Yes. What about this inelastic? Kinetic energy does not conserve, other things are conserved. Like this is an inelastic collision. So relative speed. Relative speed is a topic here, and relative speed is a concept that the speed of a moving object with respect to another moving object. So you are sitting in an aeroplane. Aeroplane is coming down to the airport, and you see a car going on the road. You see its speed from a moving aeroplane. This is relative speed. In case of relative speed, two objects are moving towards each other. You add the relative speed. What's so special about it? Speed is a scalar. Otherwise, u1, u2 cannot be both positive. After this speed of when both cannot be found, you will again add up the speed. Relative speed has a set of rule. What the rule? The rule says the arrows in opposite direction add, and the
So actually,
arrows
your
in
voice
the
is
same
lagging. I
direction up.
So your voice is lagging, so I
Okay,
didn't
can you hear
understand
me?
this part. Yeah, now I can hear you.
Let me know once you hear me. Okay. So can you give the heading relative speed?
Sure. Okay.
Now, what is relative speed? Speed of a moving object with respect to another moving object. This is the definition here. Now, when two objects are moving towards each other, like two trains are moving towards each other, the relative speed is obtained by u1 plus u2. What is the concept of relative speed? Like, for example, when humans saw the sun, they thought sun is orbiting us. Later, it was discovered that Earth is orbiting the sun. Why the mistake occurred? Because actually, the relatively they are moving. So we were orbiting the sun, but it appears it is orbiting us. Remember this rule that u1 plus u2 is a concept of relative speed, that two objects when move towards each other, their speed is added. When two objects move away from each other, speed is added. But when they're moving in the same direction, like your car is going on 80, when your car is going on 80, another car crosses you at 90, it is relative to you 10-meter more. So it is the case when you subtract the two speed. Now remember this rule. Arrows in opposite direction, speeds are added, relative speed. And arrows in same direction, speeds are subtracted. Speed is a scalar, so always plus. So after giving the heading, you have to copy this. So what we are doing in this chapter, and you will notice that I do this thing with other topics also. Whenever syllabus want, we revise the unit 1 to AS unit, I mean, and after that he will be connecting the A2, sorry, unit 4 topics in between. This is a way A2 units work. In between the unit 4, unit 5, they will ask students to make connection from the previous units.
All right, sir. Got it.
So when you see when you see the planets moving, this is an example of relative speed. What are perfectly elastic collision like gas molecules? For a perfectly elastic collision means that the relative speed of approach is equal to the relative speed of separation. They collide, this is approach. They rebound, this is separation. So this is called relative speed of approach is equal to relative speed of separation. If like for example gas molecules do that, a perfectly elastic collision is what is perfectly, we studied in unit 2 elastic collision. And what is perfectly elastic? Perfectly elastic means zero energy loss. The molecules comes in, collide and rebound. Coalesces. What is coalesces? Acha, give the heading coalesces.
Yes, sir.
When two objects collide and they stick together, this is called coalesces. Like two balls collide and stick together. You fire a bullet on a block and the block take up the bullet and move together. This is coalesces. coalesces is always inelastic because two objects collide and merge. Two objects collide and merge. This is called coalesces. Coalesces is always inelastic in nature. There is no relative speed of separation. So can you repeat what is coalesces?
So coalescence is when two objects collide and they stick together, and this
Good.
collision is always inelastic.
Yes. Now look at the formula. M1U1 plus M2U2 is equal to M1 plus M2 into V. They merge and together they are moving. You have to copy this.
Should I copy the formula?
It's better to copy the whole screen. So for a reference, what was M1, M2?
Okay, so done.
Now, how we tackle the collisions topic, elastic, inelastic, we always have to see the kinetic energy is conserved or not. Here in unit 4, we also have to consider relative speed. So we have two tools to check kinetic energy and relative speed. Now, core practical 9 comes in. I will post the practical because eventually you have to do paper 6 later. So it will be a record for you that you have to you know how to tackle these core practicals, that there are 2 points to remember. One, you have to watch some videos on them. And second, you have to print out the notes on unit number 6 for unit number 6. And then you have to make a folder for it. Definitely, you're not doing unit 6 right now, but eventually you have to do it. So when you have to do it later, but notes have to be made side by side, I'm posting the videos for your reference, and you are supposed to view the videos, and you have to tell me what you could get from here. And notes are digital, printout form is fine also. Why it is necessary to go with the core practical side by side? Because obviously later you have to do unit 5, you have to do unit number 6 also. So in that sense, your notes will be very complete, and you know that there was a unit. So I have shared the two experiments, and now I want you to refer here in your notes that you have a unit number, sorry, you have a core practical here. It is related with the chapter definitely. So give the heading core practical 9 and copy it. Okay, have you copied it?
Yes, sir.
So right under it, watch the video and notes. Right under it in a bracket, video plus notes. Now comes in two-dimensional interaction. This is a tough topic, very challenging question comes on it. Non-linear momentum. It's an example of non-linear momentum. So give the heading 2D interaction.
Yes, sir, done.
Now we move forward. This is called linear momentum. This is called linear momentum when they collide in a straight line. But like a carom board, have you played carom board? You like?
I haven't played, but I know what it is.
Okay. And what about snooker?
Yep, sometimes.
Okay. So then it's a good example. Snooker, carom board, when they hit the ball by a disc or something, they move like this. When objects move on two axes, when object moves on two axes like an alpha particle approaching a nucleus, get away by a distance, this is called 2D momentum. If particles move in two dimensions, say x and y, before and after collision, it is called 2D interaction. A very important sheet which I will post for reference, that how we solve 2D momentum. You have to look at the screen, no need to copy it, but you have to absorb the method. Remember, 2D momentum is a bit difficult topic, and you have to read the steps that how you solve a 2D momentum case. Okay.
So can you give me any example? Like how do we use?
Definitely. Definitely. That's why I'm asking, I'm not asking to copy this. I have posted on the chat. Our chat will serve as an album. We will have documents which will already will go in a document style. WhatsApp is good, but ideally, what I refer to my student that look, make an online folder like G Drive or any drive, and make folders like notes, yearly past papers, topical past papers, your homework, everything should be on that folder. Make it live on any online system so you can access it from any device. And then some folders you can link to me so I can check the homework. Everything everything in actually A level is possible if a follow up is working. I mean, if I give you some homework, school gives you some homework, and you keep on doing some questions every day, A level is not a problem. A level becomes a problem when work pile up, because everyone gets a problem in A level. O level IG is very good, but in A level marks are always challenging. You know why? Because the marking system is very tight in A level. They themselves say we can't give everyone good results. The 9 to 1 is okay with IG, but 9 to 1 is not a free lunch for everyone. Now, you have read the method. We are going to unfold the method. First, we have to see that how you resolve this vector system. You have to remember this procedure. I have posted it. Look, A and B are two objects. Can you copy down this diagram?
Yes, certain.
Now, these are the two velocities. These are the two velocities. These are the two velocities. I have resolved them. So you also resolve with me.
Yes, sir.
Now, we resolve the two velocities and then we apply the method. Remember this rule, that this formula which you had studied in unit number 2 will come here and it will be applied separately for x and y. It means in 2D momentum, you will apply this formula twice, once for the x-axis and once for the y-axis. 2D momentum comes in paper 2, comes in comes in theory paper as a open end question, and comes in unit 4 as a MCQ also. I have shared a worksheet with you on the chat. Ideally, if you can open it, if you have a parallel device like mobile phone is free, so you can open
Yes,
it.
sir. I have. It is on my mobile right now.
You're taking class on the mobile.
No, I am taking class on the laptop, but I have the worksheet open on my mobile.
Then it's very good. So we can share it now. A figure on the next page shows a collision between two pucks on an air hockey table. Puck A has a mass 0.025 kg. and is moving along x-axis with a velocity plus 0.5, it makes a collision with puck B, which has a mass of 0.05 kg initially at rest. The collision is not head-on. After the collision, the two pucks fly apart with angles shown in the drawing. This diagram will tell me in the paper that this is a 2D momentum case. I have read the question. You should also read it once, then we are solving it together to understand the procedure we have shared.
Okay, like I understood the question.
So if you have understood it, we can start it together here. And so first of all, make a rough drawing. First of all, make a rough drawing, and you have to Okay, so we are making the data together. You have to make a rough drawing, and I'm starting it with my sum of the working here. Look at this is the object coming towards the other object. The first object is at rest. I have made the data M1, M2, U1, U2, V1, V2 is question mark. Now you have to read the question, you have to make a data, and you have to make a diagram.
So just give me a second. I'm
So
5 mass of 0.050. Okay. Yes, sir. I have made the data.
Good. Now they collide, and in these questions, the most important thing is situation before collision and situation after collision. After collision, this is the situation, so I will resolve it. So now this is my free body diagram. I call it free body for my understanding. Obviously, these are not forces, these are velocities, but we used to use this word. So now look at this 5.5, 0, and everything. I'm resolving it. Now, this is the important diagram because here I know some momentums are on x-axis and some momentums are on y-axis. You can notice that I'm showing velocities. I'm not showing mass deliberately. This is one of the two approaches. But one approach says solve in velocity and introduce mass later. Or second approach, solve in momentum and directly get the answer. So now you have to copy this diagram of vectors, vector diagram.
Yes, sir. I have already made the diagram.
So now we can roll over the method. Look, the first thing I'm applying it for x-axis. I have highlighted for x-axis two vectors v1 cos, v2 cos, x-axis. On the left side, there are two. I want to apply this equation. Total momentum before collision is equal to total momentum after collision. So you have to now make the equation for, give the side heading for x-axis and make the equation according to this pattern.
Should I write the values?
Write the
Like, should I put the values into the formula?
ah,
Okay. So it will be 0.025 into 5.5 plus 0.050 into 0. Then the mass is 0.025 into uh, so do I need to use the vertical component or the horizontal?
no, right now we are working for x-axis. You can compare the equation with me on the screen.
Okay, so we have to find the values for, like, first we have to solve for x-axis, then separately for y-axis.
Hmm? Sorry.
We have to solve it for the x-axis and the y-axis separately, right?
You will make two equations. Na? You have to first
Okay.
compare the first equation with me. If it's matching, then we go for the second equation.
Yes, I made the same equation.
Good. Then we move forward for our y-axis block. Look at the y-axis block.
Yeah.
There is no initial velocity on y-axis, so it will be a big zero before collision.
0.03. Yes, sir, I made the equations.
Now we have two equations. I have made V2 subject. You can make anything subject from the second equation, V1 or V2.
Okay.
Now, these are the two equations you have to solve and get the values of V1 and V2.
So I just need to substitute the value.
You have to take V2 from the first equation and put it in the second.
So can't we do it like first we find the momentum of each particle, after the collision, momentum after the collision for V1, like for the particle A, then for particle B, and then we use the law, the momentum is conserved before and after collision, and then we just find the speed from that.
That's the same thing, but actually there are two unknowns. Na? Even if you try that approach, I already told you in the start that there are two thinking process. One, solve for velocity and then develop momentum, or solve for momentum and then solve. Doesn't matter. It is not a problem. If you remember that way, you can try that. If you remember it fully, if you do not remember that method, then you can try this method. It's the same thing. Actually, you know why? Mass is not going to resolve. Momentum is mass into velocity. If you resolve momentum or you resolve velocity, it's actually the same thing.
Mm,
You
yes.
need to find the two velocities which will remain unknown, whatever route you will take.
Okay. 0.135 minus 3.350. So the V1 is 10.115 and the V2 is
I'm getting V1 as 3.37.
uh, okay, let me just redo the calculation.
No problem. Just write down the answer, put it redo for later work.
Okay, V1 is 3.37 The V2 is. So what is the value for V2?
I'm getting V2 as 2.54.
Fine.
So note down the values.
Yeah, I have noted down the values.
So these are the two values. So this is one complete question on that. And the worksheet has one more question which you do at home as a homework.
Okay.
Now we complete our momentum job, and here is the last title here, explosions. Explosions are like those conditions where objects get away from each other, like nuclear fission is an explosion. So when objects break down, the one of the biggest example which can be given is the Big Bang. Big Bang is an example of an explosion which science believe is the start of the universe. So an astronaut with a jetpack used a fire extinguisher to power a small vehicle, supernova, nucleus decays into daughter nuclei. These are called explosion. So give a side heading, give a heading, explosions.
Okay, sir.
Okay. So look at this example, which I'm taking from the past paper. I have an unstable nucleus, which is initial momentum zero, initial kinetic energy also zero. Nucleus is sitting at rest, calm and quiet. Okay, now copy down this example.
Okay, sir.
Right. Now the nucleus breaks. Nucleus decays into daughter nuclei, and the two nuclei after decay move opposite to each other. Why they have to move opposite? So that the momentum is conserved. And how momentum can be conserved? Momentum will be conserved because one of them will be plus and one of them will be negative. Look at this very interesting rule that in this case, momentum has to be opposite.
Yeah, it has to be negative so it cancel out the effect.
Yes.
So should I draw this diagram? The
No,
previous one?
not required. So now give the heading, sorry, give the reference that is our next heading for our next class. This is a way that I have to keep a record also. Kinetic energy of a non-relativistic particle. Momentum part is complete. And we have covered unit 2, we have covered unit 4, we have covered 2D momentum. And now we will start this title, kinetic energy of a non-relativistic particle. We have to give this heading.
Yes, sir. Done.
So we are stopping here and we will inshallah continue in according to our pattern. You have told me Tuesday you're busy, so I will try to switch the class. And otherwise we will compensate it in the on the weekend. And our target is to cover the title in approach of topical. In the last, and you have to tell me that are you having any past paper books like when you prepared unit number 2, did you use topical past papers?
So actually, I did not get enough time to practice for past papers.
But no, no, no problem.
The
But
last.
Did you buy them? I mean, if you have the books, then I'm not asking you to buy
No, no, like
anything.
I don't buy the past papers. What I do, the past paper, I firstly prefer to solve them online. I mean digitally. I have a tablet, so I solve them online and keep them saved in my Google Drive. And
Hmm.
if I really need to do them on the paper, I have a printer. I just take out the print on that moment. I don't buy anything in advance.
I know printed books are no printed books are available. I know, but they are very expensive. I know the issue, but anyways, let's see how we can work it out. Digital is the last option always. There are stationery shops available who gives topical paper 2, paper 4, paper 5. So they give a bundle of paper 4, 5, bundle of 1, 2. Acha, then the time is very less. So I think digital would be fine because it's
Yeah.
only just half of the more than half the number is gone. So I think it will be very late to buy the books. And Edexcel want people to solve in writing because of the paper effect. The digital cannot do that. But we have so much less time. Did you get the dates?
It is somewhere like around 10 Jan or 8 Jan. I'm not sure, but it
Ah, but,
is in the
but
beginning
around
of
that,
January.
it always comes like that. Okay. So we are
Yes.
stopping here. We will inshallah continue in our next class. Thank you. Allah Hafiz.
So one thing, if you
Yeah.
have if you have the topical past papers with you, the digital version, please share that with me so I'll
We
try
will
to solve some of
we
my own.
we will start rolling that. Even obviously we have to start from you have to start unit 2 also. You have to start unit 2
Yeah,
yourself and we can go
I
to
first started myself. Yeah.
I will inshallah, I've started sharing the material. I will inshallah share all the things one by one every day. So you can start rolling the process. Don't worry, inshallah. Okay? Thank you. Allah Hafiz.
Allah Hafiz.